Hello guys, hope you all are doing well. So in the continuation of the previous grade series, we have completed the section A of 1995 and we will start today section B of 1995 and I'll upload 1995 in two videos. Okay, so because it is difficult to edit the video when the video is very long. Okay. So without wasting time, we'll look into the question. So the very first question is the rate of increase of number of bacteria under certain condition is proportional to the number of the bacteria. If the number doubles in 4, this is hours. Okay, this is not Bose. Hours. How much increase in the number of bacteria can be expected after 12 hours? Okay, so very first thing, the rate of increase of the bacteria is directly proportional to the number of the bacteria. So this is the equation where n is the number of the bacteria. Okay, we'll remove the proportionality sign, then a constant will come. Okay, then this become dn by dt is equal to kn. Now dn by n is equal to k dt. Right, now integrating this. So integrating this at t is equal to 0, initial number, that is n naught, at t is equal to at some time, n will be the number of bacteria, some bacteria. Okay, so we'll get this equation. Okay, property of log and n is equal to 2n in t is equal to 4 hour. Okay, so we'll put the value, we will get the value of k, right? Now what is the number of bacteria in 12 hours? So basically since we do not have the initial number of bacteria, so it will come the multiplication of the initial number of bacteria. Okay, that is n naught. So we have k. Now applying the same equation after 12 hour, just we have put it the value. Okay, in this equation we have k, we have time, then we will get n by n naught is equal to 8. That means whatever be the initial number of bacteria, the quantity, the amount of bacteria after 12 hour will be 8 times of the initial number of the bacteria. So n is equal to, at t is equal to 12 hours, will be 8 times of the initial number of the bacteria. Okay, so you can choose any value. So this is straightforward question just to check your basic knowledge, and I don't think so this type of question will come again. Okay, so methanol is produced by a reaction of CO with H2. So there is a reaction, that is CO plus H2, that gives CH3OH. Only 15% of the carbon monoxide entering the reactor is converted to methanol. Okay, methanol formed is condensed and recovered completely. That means, okay, I'll explain it later. The unreacted CO and H2 are recycled back to the reactor. The feed will contain H2 and CO in the ratio of 2:1. So 3200 kg per hour of methanol produced. Calculate. Kilomole or kg mole is same. Fresh feed, recycled gas, molecular weight of 32. Okay. So at first we will see the diagram. See what it is saying. Methanol formed is condensed and recovered completely. That means in this stream there is no unreacted CO and H2, and in this stream there is no converted methanol. No converted methanol, CH3OH. Right. Whatever the methanol is produced, the condenser condenses it and we are recovering it completely without having CO and H2 in the product stream. The unreacted CO and H2 is recycling only. The question is very clear. Okay, so very first thing, the conversion rate of carbon monoxide is 15%. Okay, that means if we will divide for 3200 kg per hour, that means 100 kilomole per hour. I just completed it to kilomole. We will do our all calculation on kilomole basis. So see, this is mixed feed, because it is F is coming from here, R is coming from here. Okay, so F plus R is equal to M. This is the basic equation. We know M is equal to F plus R. So when it is saying that the H2 and CO in the feed is 2:1, it is saying in the mixed feed, in the M. So CO in the M, 100 divided by 0.5. That means this amount is we are feeding to the reactor, and only 15% of this amount is converted to the methanol. That means 100 kilomole. Because reaction will, whatever be the reaction, it is in the reactor only, not in the condenser. Condenser is just for the separation of the components. Nothing else is doing condenser. The reactor will do all the reactions, necessary reactions. Okay. So after this process, we will just separate the things which we want, which we don't want, desired, undesired. Okay. So CO in the M will be this. Now, the twice of this value will be H2. H2 in M, 2 into this, right? So total M will be summation of both. Okay, 200 kilomole per hour. Okay, now CO converted by the reaction. Since we have the reaction, okay, CO plus H2, that is CH3OH. So CO converted 100 kilomole. Okay, mole of CO. Oh, sorry. So CO converted, mole of CO, mole of methanol into 100. So 100 kilomole. H2 converted by the reaction 100 kilomole. Okay. CO unconverted, which is feed and which is converted, that minus which is converted will be the unconverted. H2 unconverted, this is the feed, this is converted, this is the, nothing else is going any of the component. So adding of these two will give the recycle. Okay, so will this will give the recycle. So apply overall balance on point 1. What I said to you earlier, that F is equal to R plus M is equal to R plus F. So F is the 2. So recycle is 1800 and F is equal to 2. So this is straightforward question, but I want to give a tip that when you are going for actual examination of GATE, try to attempt the process calculation in the end, because no matter how strong you are in the process calculation, it will take time. It will take time to think. If the language, if the those who are setting the question paper, if they will change the language a little bit, just like the probability, if the little bit language change in the question, then you will got stuck. So just to go for all the other things first and attempt the process calculation in the end if possible, and it is just my suggestion. That is totally up to you, what is your strategy of the paper. Okay. For first order reaction taking place in an isothermal batch reactor. Okay, 80% of the liquid reactant is converted to product in 15 minutes. Sorry, 80% of the liquid reactant. Okay. Calculate space velocity required to achieve the same in the plug flow and the back mix flow. Okay, so we will solve this analytically. Not like we will solve analytically, but with pen. So for first order reaction, minus Ra is equal to KCA. Performance equation of batch reactor, you know that T is equal to Ca naught dxa upon minus Ra 0 se xa. And what is the performance equation of plug flow reactor? It is exactly the same, isn't it? Okay, so whatever the time for batch reactor will be equal to the plug flow reactor. So it is saying what is the space velocity. We know that space velocity is inverse of the space time. So for plug flow reactor, it is 15 minutes. So it will give 0.0666 if I'm not wrong. This is the ratio, I think 0.066. Just check it. Just check it. Okay. For tau for CSTR, CA naught x1 minus x naught k CA naught 1 minus xa. 1 plus epsilon a xa will not come because epsilon a is equal to 0 because liquid reactant. Okay. So CA naught and CA naught will cancel out. X1 is 0.8. No converted feed. K is 15 minute. Okay. So we need to find K with this equation. So T is 15. 1 by K minus ln 1 minus X. So 15 minute is equal to 1 by K. If you will solve this equation, it will give ultimately this. So K we need to find minus ln 1 minus 0.8, 0.2. So K will come 0. Where is the cursor? 0.1073 minute inverse. I will put the value here. 0.1073 minute inverse into 0.2. Okay. So it will give the value 37.28 and space velocity 1 upon space time. Okay. So this is straightforward question. Okay. The Orsat analysis of a flue gas CO2, O2 and N2. That means this is the final composition of the flue gas. So it will give CO plus half O2, that gives CO2, right? So here we have in the end product CO2, O2, N2. N2 is tie component, so it is always be there in the feed as well as in the product because it contributes from the air only. Oh, it is written here, contributed by the air only. Okay. Determine the present excess air used in the determine the percentage excess air use. Okay. So very first thing, what we need to find percentage excess air. So a formula is air fed minus theoretically required divided by theoretically required. Since there is no CO in the reaction, there is no CO in the end product, so these three only are the major components. So very first thing, N2 is here. Okay. And let final gas composition will be 12.7 kilomole. If I take final gas composition as 100 kilomole, then the quantity of CO2 will be 12.7 kilomole, O2 will be 7.1 kilomole, N2 will be 80.2 kilomole. But the same quantity will present in the feed as well because it is a tie component. It will not react with any other component. Okay, any other component. So air fed, I can find out how 80.2 divided by 0.79. It will give 101.52 kilomole. Just write it. I will not write air fed. So O2 fed in the reaction 0.21 into 101.52 is equal to 21.32, right? O2 left 7.1. This is the O2 unreacted because it is in the end product. So O2 reacted 21.32 minus 7.1, it will give 14 something, 14.22. Right, this is O2 reacted. So air theoretical required will be is equal to the 14.22, because O2 reacted is equal to the O2 theoretically required divided by 0.21. This will give the value of 67.7. So we have everything. O2 fed 101.52, O2 theoretically reacted 67.7 divided by theoretically required into 100. It will give around 49.9%. Okay. Okay. This is important question. Pure CO is mixed with 100% excess air and burned. Only 80% of CO burns. Okay, 80% of CO burns. The reactants are at 100 degrees Celsius and the products are at 300 degrees Celsius. Calculate the amount of heat added or removed per kilomole of CO fed to the reactor. Okay, so we are feeding only 1 kilomole of CO. That means 1 kilomole of CO we are feeding. So see, without stoichiometry, this question cannot be solved. Okay, so very first 1, okay, and then air, it will 80% CO burns. That means CO2 is equal to 0.8. CO will be 0.2. This is end product. Now we need to find O and O2 and N2. Okay, so very first thing, 100% excess air. So percentage excess air is equal to air fed minus theoretically required divided by theoretically required. Okay, so excess air 1, because 100% is equal to air fed we want to calculate, theoretically required. So theoretically required air will be so see, in the reaction O2 theoretically required 0.5. So air theoretically required 0.5 divided by 0.21. Okay. So 0.5 divided by 0.21. 2.38 is equal to 2.38. Now, so put here 2.38 upon 2.38. So 2.38, 2.38. So air fed will be 2.38 into 2, 4.76. 4.76 is the air fed. Now, N2 in air, N2 in air 0.79 into 4.76, 3.76, 3.76. O2 in air 1. Okay, 4.76 minus 3.76, O2 in air 1, or you can find 0.21 into 4.76, it will give 1. Okay, now we have everything. So feed we have CO, N2 and O2. CO is 1, N2 is 3.76, O2 is 1. But O2 reacted 0.5. So O2 here is 0.5 and N2 is a tie component 3.76. So now we have all the N, we'll apply energy balance. So this is the equation when stoichiometry and energy balance combines. Calculating delta H. Very first we will calculate delta H of reaction, because directly delta H of the reaction is not given. This is given like this, standard heat of formation. We know that standard heat of formation, that is standard heat of reaction, will be moles into product minus the reactant. So 1 minus this is for product, minus 1 into minus this, so this will give the value. Okay. Second, delta heat of product. Now since product is at reactant is at 100 degrees Celsius and this is at 300 degrees Celsius. So uh, we know that the formula is in a general way NCP T minus T reference, and reference is always 298 Kelvin or 25 degrees Celsius. So we'll apply that. We have everything. Okay, very first we are calculating for product. So 0.2 is for CO because CO is unconverted. 0.8 is converted. So 573, that is uh, 300 plus 273. 573, 298 is a T reference temperature. Similarly, this is for CO2. This is for 0.5 O2. This is for N2. So we will get this. For reactant, one is for CO, one is for O2 because we are feeding it. It is converting later, and 3.6 is for N2. So we will get this. Okay. Put all the values, you will get this. So it is coming in minus, and this is heat released. Okay. So since these type of questions will take time, so always go for process calculation at the end. Okay. And in fact sometimes what happens, section that journal aptitude, I think that aptitude section is so easy, so no need to go for process calculation as well. Okay, if you are scoring enough marks in aptitude section. Okay, this a pressure filter is operated in a constant rate mode to yield 10 meter cube in the first 10 minutes. Constant rate 10 meter cube volume in 10 minutes. As the operating pressure increases from 0, in the next 20 minutes, it is not saying in the at after 20 minutes later, it is saying that 10-20 minutes later, next 20 minutes, the filtration was continued at constant pressure, after which it is stopped. Okay, estimate the total volume of the filtered obtained during the filtration. Okay, during the both cycle, constant rate and constant pressure. Estimate the washing rate at the end of the filtration. Washing rate. Okay, also determine the washing time of the volume of wash liquid equals to the volume of the filter rate obtained. Neglect the filter meter resistance. Okay, so very first thing, we know the basic equation. This is the basic equation. Filter medium resistance is 0, that means beta is equal to 0. We will get this. Now case 1, constant rate mode, this become this. Applying formula, K is this. So K is constant in all the process while we are using constant rate or constant pressure. Okay, now constant pressure, this. Okay, now we will solve with pen here. So integrating it. Okay, so T we have 20 minutes. In the next 20 minutes, K we just point 0.1 meter cube per minute into V square. What is the value of K? Meter cube minute, meter की power 6 per minute, meter की power 6, it is not cube, meter की power 6 because volume square. Okay, so meter की power 6 into volume square by 2. Sorry, I made a mistake here. K is equal to T by V square, T by V square, K is equal to T by V square, T by V square, T by V square. So it will give minute per meter cube, meter की power 6. Okay, so minute meter की power 6. Okay, meter की power 6. So K is 0.1 V square, so 40 minute divided by 0.1 minute and minute will cancel out. Meter की power 6 will come is equal to V square. So So V is equal to 20 meter cube. So at constant pressure volume is 20 meter cube. Now T wash, we know that T wash is equal to volume of wash water used divided by rate of washing. So rate of washing in pressure filter is equal to the rate of the filtration. So volume of wash water use is 1. Rate of washing will be dV by dt. That is equal to 1 by kV. So 1 by k is 0.1 into volume. Total volume will be, this is the total volume in the constant rate as well as in the constant pressure. So 20 plus 10, that is 30. So it will give around 1 by 3. Okay, so 1 by 3. Okay, 1 by 3. This is the rate, 1 by 3. Okay, rate of washing. And okay, and volume of wash water used same as the volume of the filtrate, that is 30 meter cube, and this will give the value of meter ki power 6 per minute. So meter, this will cancel out, it will give 90 minute. Okay, so we have calculated T wash, we have calculated rate, and we have calculated the volume in the pressure. Okay, so this is the question. If you have any doubt, anything or something in this question you are not able to understand, just comment it. I'll try to reply as soon as possible. Okay, bye guys, take care.